For our final lesson on complex numbers, we're going to look at an interesting property that's uncovered when we have I raised to different powers. A few lessons ago, I mentioned that I is somewhat cyclic. They are not cyclic in the sense that these sine and cosine functions are, if you're familiar with trigonometry. Notice how these produce a wave-like graph. But I shows a pattern with each incremental value of n. Let's start listing the values of I to the n for n between 1 and 4. For I to the 1, we have I, and for I squared, we have -1. We know these two already. For I cubed, it can be rewritten as I squared times I, which equals -1 times I, and then equals -I. Look at I to the 4th power. That can be rewritten as I squared times I squared, which equals -1 times -1, which equals 1. As n increases from 1 to 4, I changes from I to -1 to -I to 1. Let's see what happens to I to the n for n between 5 and 8. For I to the 5th, it can be rewritten as I to the 4th times I, which equals 1 times I, which equals I. For I to the 6th, it can be rewritten as I to the 4th times I squared, which equals 1 times -1, which equals -1. For I to the 7th, it can be rewritten as I to the 4th times I cubed, which equals 1 times -I, which equals -I. I to the 8th can be rewritten as I to the 4th times I to the 4th, which equals 1 times 1, which equals 1. Once again, our values of I cycle through I, -1, -I, and 1. Since I repeats 4 cycles of n, we can find the value of I to the n for any positive value. Definition: for all n greater than 0, I to the n equals I to the r, where r is the remainder of n divided by 4. So for example, if you have I to the 19th power, we take the remainder of 19 divided by 4, which is 3. Thus, I to the 19th equals I cubed, which equals -I. Let's look at a couple more examples. Number 1, I raised to the 100th power. We have here a very large exponent. Luckily, we don't have to worry about evaluating a value 100 times when it comes to the imaginary unit. Let's take the value of the exponent and divide it by 4 to find the remainder. Since 4 divides 100 evenly 25 times, we have no remainder. Thus, the power of I can be rewritten as I to the 4th equals 1. Number 2, -I raised to the 13th power. It's very easy to be tricked by that negative sign. Notice that the exponent is raising the power of I, not the power of -I. So first we recognize the remainder of 13 divided by 4, which is 1. Thus, I to the 13th power equals I to the 1st power, which equals I. And therefore, -I to the 13th power equals -I. Number 3, 1 divided by I raised to the 83rd power. Here we have our imaginary unit in the denominator. We're going to leave it here first, because we don't want to have a negative exponent. First, we'll find the remainder of 83 divided by 4. If you ever need help with some large numbers, remember that 80 is twice of 40. 40 divided by 4 is 10. So we know 80 divides by 4 cleanly. That leaves us 1, 2, 3. So the remainder equals 3. Thus, this can be rewritten as 1 divided by I to the 3rd power, which equals -1 over I. We're not done yet. Just like in the last lesson with division, we're not simplified if there is an imaginary unit in the denominator. Let's multiply by I divided by I. We get negative I divided by I squared, which simplifies to negative I divided by negative 1, which equals I. Number 4, I raised to the negative 25th power. Remember our definition for the powers of I. If we're going to simplify it, the exponent must be a positive number. So let's fix that. This becomes 1 divided by I to the 25th power. When 4 divides 25, we end up with the remainder of 1. So we get 1 divided by I. Using the rules for dividing imaginary numbers, we end up with negative I. Well, we have arrived at the end of our journey through the prerequisites for algebra. To be honest, this was only a very brief look relative to the amount of information brought forth. There's so much more that can be looked on, but I think it's time to move on. Next time, we'll be in algebra, and we'll start our study with equations and inequalities. I hope to see you there, and thanks for watching.